Hey students, today we are going to discuss the past papers of heating and cooling curves. These are some of the topical questions from the year 2016 to 23 related to heating and cooling curves. Let's start. So it has some P2 questions and some P4 questions also. So when you will solve these questions, so you will get an idea that how the questions will come about heating and cooling curves and how to solve them. The first question is, substance M is a solid at 30 degrees Celsius. A substance is heated to 80 degrees Celsius and its temperature measured as it cools down to room temperature. The cooling curve is shown. So, this is a cooling curve and the substance M is solid at 30 degrees Celsius. Now we have to see the question. You have to read the question very, very carefully. These are the options. Number 2 should be here. These are the options that between which time is the substance M freezing. Okay, so we have to see that where it is freezing. Freezing is when liquid changes into solid. So we have to see that at which temperature it is liquid and at which temperature it is solid. So the question is that it is a solid at 30 degrees Celsius. So it means above 20 and below 40 somewhere here, it will be 30. So if we make a line, don't forget to use a scale. If we make a line like this, so it means that between solid and between R and S, the substance is solid. So before solid, when you get a straight line, this is when something is freezing. Because in heating and cooling curve, there is a very important concept that when the temperature is same or when temperature it it stops to rise or down, the temperature remains same. So this means that some phase is changing during that time. So when the temperature is constant, a phase is changing. There's a phase change. So a substance is solid at 30. So before that, when the temperature is same between Q and R, this means that between Q and R, the substance is freezing. And P to Q is liquid. And it is freezing at QR and it becomes solid and R and S. So the option P is correct, which says Q to R is freezing. I hope you have understood. Then we have a next question. Part of the cooling curve for water is shown. What is occurring between points X and Y? So it's a cooling curve as we know that at 100 degrees Celsius, the water boils. It is the boiling point of water. And if it is a cooling curve, then boiling point will be the same as condensation point. So at this temperature, it has turned into liquid. And at 0 degrees Celsius, it is freezing. Again, the temperature is the same, which means it is freezing during this time. This is a phase change and then it becomes solid. So what is occurring between X and Y? Let's read. Steam is condensing into water. No, because here the liquid is changing into solid. The temperature of the water is decreasing. Temperature of the water is decreasing. No, because here the temperature is the same. Ice is melting. No, because it's a cooling curve. Particles are losing heat to the surroundings. This is correct. Because in cooling curve, the particles release their energy and come together to turn into from liquid to solid. They freeze, they solidifies. When they lose energy, become slower and come closer to each other. So when they come closer to each other, they turn into solid state. Question number 3. Nitrogen is heated in a balloon which expands slightly. Expands means it increases in size. It increases in size. Which statements about the molecules of nitrogen are correct? So it expands, they move further apart, they move more quickly, they remain the same distance apart and their speed remains unchanged. So, as the balloon is heated, so the speed will increase. So this is wrong because the speed will increase as we increase the temperature. And if the speed will increase, they will move far from each other. So the distance, they remain the same distance apart. This is also cross because the distance will increase between them. So statement 1 and 2 are correct. They move farther apart and they move more quickly. Option A is correct. Next question. A solid X is heated for 600 seconds. The graph shows the heating curve that is obtained. So this is solid and we are heating it. What is the melting point of X? Very easy question. We are heating the solid. So it means here it is solid when the temperature is rising. It's solid. And it turns into liquid at this point. So this line here to here, this straight line is melting when solid is changing into liquid. So we can just extend it backwards. Again, don't forget to use the scale and voila, you can find from here. It is 170 degrees. So B is the answer. So that's how you can find out the melting point or boiling point of a substance, because at that time, when the phase is changing, when something is melting or boiling, the temperature is the same. And you can extend it backwards to find out that what is its value on the temperature axis. Next question. The gas is placed in a sealed container. The gas has a pressure of 1 atmosphere and the temperature of 50. It is heated to 100. Which row describes the cause of the pressure of the gas and the effect of increasing the temperature of the gas? So, the pressure is 1 atmosphere and the pressure is the same in the gas. So, what happens with the pressure? The collision between the gas particles, the gas means the pressure affects the collision between the gas particles or the collision between the gas particles and the container. So it collides with the gas particles and the container as well. So particles, they collide with the walls of the container also. And effect of increased temperature, when the temperature is increased, then the kinetic energy of the particles also increases, which directly affects the speed of the particles. The movement of the particles also increases. So the answer is D, because the average speed of the gas particles increases as the temperature increases. So option D is correct. Then we have some P4 questions, structured questions. Let's see. The graph shows how the temperature of the substance changes as it is cooled over a period of 30 minutes. So it's a cooling curve. The temperature is going down. And as I told you, when there is a phase change, the temperature remains same. So here, as you can see, that this line and this is the line, these are the two lines which are straight. It means that these two lines represent some kind of phase change. So when it is a cooling curve, so it means the gas is changing into liquid and the liquid solidifies into solid. It solidifies, it freezes. So that's a cooling curve. So which letters S, T, V, W, X, Y, or Z shows when the particles in the substance have the most kinetic energy? So we have to use these alphabets to tell the answer. The particles, at which stage the particles have the most kinetic energy. Okay, first think that solid, liquid, gas. Which particles have the most energy? Which state? Yes, you are right. Gas particles. Gas particles have the most energy, right? They move the fastest. They have the most energy. And also, if there is a high temperature, then the particles move much, much faster. They have more kinetic energy at that time. So it means at point S, the particles have the most energy. First of all, it is a gas. Secondly, It has a very high temperature, the highest temperature here. The particles in the substance are furthest apart. They are furthest apart again in S, because these are gas particles and they are moving very fast at very high speed with the most kinetic energy. So they are further apart also. The substance exists as both a gas and a liquid. So this is a gas. We are starting the cooling curve from the gas and then it turns into liquid. Remember, when the temperature is changing, when the temperature changes, it is some kind of state. When the temperature is changing means whether if it is a heating curve, then temperature increases in heating curve, and if it is a cooling curve, then temperature goes down. So when the temperature is increasing or decreasing, it means it is some state, gas, liquid, or solid. And when the temperature is same, when the temperature is constant, it means that the phase is changing now. Okay? So a substance exists both as gas and liquid. So at V, it is the gas particles are changing into liquid. It is a condensation. This V is representing condensation process. So answer here is V. Use the graph to estimate the freezing point of the substance. Okay. So freezing point is when liquid changes into solid. Here, as you can see, this is liquid and Y to Z is solid state. In the middle, where there is a straight line, then the phase is changing and this is freezing. Liquid is changing into solid. So this line, the straight line is representing freezing. And if we want to identify the freezing point very carefully by using a scale, we can extend it backwards. And here, between 100 and 150, not in the center, but slightly above the center. So it could be 140. Okay, it is 140, 135. So in this type of question in which you have to estimate or predict the value, then you can write the range or you can write any number between the range. Right in here, in this question, your answer should be between 130 and 145. So between 130 and 145, you can write any value because here there is no proper graph. We don't have the markings here between 100 and 150. So between these two, you can write any answer. So between 130 and 145, you can write any range. Name the change of state directly from solid to gas. Do you know the answer? It is? Yes, you're right. It is sublimation. Okay, next. Okay, we have next question. The graph shows the change in temperature as the sample of gas is cooled. Name the change of state taking place between A to B. Okay, so a sample of gas is cooled. Everything is given in the question. Just you have to read the question properly. This is a gas and it is cooled. So when we cool the gas, it changes into liquid and it changes into liquid through the condensation process. So this phase, when the temperature is the same, it is representing a phase change, which is called condensation. So the change of state is condensation. Okay. Now this question is not related to the heating and cooling curves, but it's just common sense question. And it's also included in this chapter, which is diffusion. Like when you open a bottle of liquid perfume, it's left open at the front of the room. After some time, the perfume is smelled at the back of the room. Name the two physical processes taking place. So one physical process is diffusion, which I think you all know that diffusion is the movement of particles from high to low concentration. And the second process is dissolving. So it is dissolving, spreading into the room, and diffusing also. Okay. So I hope You get this worksheet and you get each and every question which is present in this past paper, compiled past papers. I will make more videos like this, so please subscribe to my channel if you want to see more videos on the topical past papers. This is chapter 1. I'm going to make the more worksheets also, more topical worksheets also. So please subscribe, like, and comment if you have any confusion. Thank you. I'll see you in the next video.